We saw ACI, VXLAN, VXLAN, how VXLAN is involved in ACI. We also saw loop prevention in ACI. Now, these are the things that we spoke in the previous class, VXLAN and ACI, intra-EVPN traffic, intra-EPG. It is by default allowed, but inter-EPG, we need to write contract. We spoke about setting some limits so that Strom can be controlled, traffic load balancing. We spoke different algorithms in load balancing, loop prevention. All this we discussed. Today we are going to focus on two different topics, two different chapters in ACI. Number one is connecting to the external network. How do we connect and why do we connect? Simple. Why we connect and how do we connect? If you know, that's all this topic is. Let's see. Why do I need to connect? Again, next question will be, is it a layer 2 or layer 3 connection? Is it layer 2 out or layer 3 out? If it is layer 2 out, what does it mean? It means that I want to extend the broadcast domain outside ACI. I repeat, when you say layer 2 external network connectivity in ACI, what does that mean? ACI has got some traffic which is in a particular broadcast domain, maybe VLAN 100, and you want to extend that VLAN 100 to the traditional layer 2 switches. You have ACI, you have traditional network. You have traditional catalyst switches. You want to extend the layer 2 of ACI down to the catalyst switches, classical switches. It can be multiple VLANs, so it can be a trunk also. You want to extend the trunk to the classical catalyst switch. So the layer 2 is not within the ACI fabric. Layer 2 is even extended beyond to the catalyst switch or to a router also sometime. Just a layer 2 extension to the router. Router may act as a gateway there. That is what it means when we say layer 2 external network connectivity. Now, what is layer 3 external connectivity? ACI fabric is extended to outside a router or a firewall. We are going to see this thing. So this is what actually it means, external network connectivity to ACI. You may want to connect to the internet. So the ACI fabric is getting extended down to a router so that all the members of the ACI can also go online and talk to the public, ISP. There is layer 3 out. Layer 2, layer 3 external network connectivity in ACI. But this is totally automated because ACI is an application-centered infrastructure. We don't need to do any CLI configuration manually. We are going to use the templates. We are going to use the EPGs. We are going to use policies and profiles to do this. So here, while ACI primarily focuses on managing intra-fabric traffic using policies, there are scenarios where communication with external network is needed. This is the requirement why we need to learn this chapter. ACI focuses on within the fabric, that is true, but in some cases, as I said, you want to have ACI as well as your traditional old network. You want both together. For some period of time, you couldn't migrate completely to ACI. You want to balance between the old and the new. So there is need for an extension. Or you want to talk to the internet through a router which is outside the ACI fabric. External connectivity in ACI enables communication between ACI fabric and external devices such as legacy network. That's what I was talking about. Traditional network, legacy network, firewalls. For inspection, you don't have ACI VMs inside the ACI fabric. You have an external firewall outside. Or you want to have a WAN connection, maybe MPLS, VPN. So you need to go to a router. Or there is a service provider network outside you want to communicate. These are the examples or scenarios where we need external connectivity. Now, use cases, I think we just spoke. Connecting an ACI fabric to an external traditional network, which is also called as brownfield deployment. It's neither black or white. Within ACI fabric, we consider as white. Outside, this one is brown. This is not bad. It's not black. It's not dark. Dark. It's still visible, but not ACI. Providing connectivity with internet or WAN. We already spoke this example. Integrating firewalls and load balancers, which are outside the fabric. Hybrid cloud connectivity. So you got another cloud. ACI itself is a kind of a data center cloud. You want to connect to another data center cloud or on-prem to cloud. On-premises to the cloud. Let's put on-prem to cloud. On-premises, you have ACI, and you got another big cloud or another ACI. Then again, external connectivity is needed. Interconnecting multiple data centers. So for these reasons, we will think about external connectivity. As I said, we are going to focus on layer 2 external network connectivity, which is called as layer 2 out, and layer 3 external network connectivity, which is called layer 3 out. Now let's go back and see layer 2 out. Layer 2 out allows ACI to extend layer 2 domains to external switches, routers, and legacy networks. Basically, a broadcast domain is getting extended. It's not within the ACI boundary. It goes outside of the ACI fabric, stretches outside. It can be a single VLAN or multiple VLANs. This is typically used when we need to stretch VLANs, meaning trunk, outside the ACI fabric. Scenario for L2 out. Extending layer 2 for migration of from traditional network to ACI. This is like temporary during the migration phase someone can do. First, we have a traditional network. Now we just are trying to deploy an ACI. We are trying to deploy ACI in our premises. So we slowly migrate. We just extend that VLAN from traditional to ACI, and then we start moving the end devices to ACI little by little, so that the entire network won't go down. So in some point of time, there will be some devices in traditional network, some devices in ACI fabric need to communicate. For that, you need to put them in same broadcast domain. Secondly, integrating existing non-ACI environment with ACI. For me, basically both points are same. Traditional network is also a non-ACI. Connecting external firewalls for applications that operates at layer 2, very important. You have a firewall that operates in layer 2 or application that operates in layer 2, then you need again layer 2 to be extended. We call this layer 2 out. Now, how this layer 2 out works? Bridge domain inside ACI is associated with external bridge network. I was saying a word called broadcast domain, which is representing single VLAN. But bridge domain is what the term that we use in ACI. But a bridge domain may have more than one subnets. Broadcast domain will have usually one subnet. So this is the step. First of all, bridge domain, which is inside the ACI, need to be associated with external bridge network. When we do the configuration, when we see the configuration step, you will understand this point. It is in the next page. ACI leaf switch connects to the external device via trunk or access port. We already discussed. Traffic forwarding decisions are made based on MAC address only because it is L2 out. Now this first point, bridge domain, which is inside the ACI, needs to be associated, mapped to the external bridged network. See here, for example, here we are configuring a L2 out. We have a bridge domain. See, ACI needs to connect to the external switch where VLAN 100 needs to be extended. VLAN 100. Now, you need a bridge domain. How to create bridge domain? This is a step. Tenant, networking, under which you have bridge domain. There you click on create or plus sign and associate it with the required VRFs. Enable flooding and ARP learning if needed. This is an optional one. Now going to the second, this is how we create bridge domain. Now going to the second point, which is external network, L2 out external network, which we saw here, no? External bridge network, L2 out. We saw bridge domain, how to create. Now we are seeing external bridge network. Tenant, networking again, same place. We come out of bridge domain, we get into external bridge network, in which we create L2 out policies associated with the bridge domain, which we already created in step 1. And then we define which VLAN the traffic belongs. That's VLAN encapsulation. That's all. This is the very first point and or the only point which is needed to configure L2 out. You see? Then configure static paths. Assign a leaf port to an external switch. Means you connect a wire from the leaf port. Define the encapsulation type like VLAN 100 or trunk. This may not be needed if it is intra EPG. It is actually an intra EPG most of the time. You're just taking on bridge domain and mapping it to external out. So contract will not be needed. If needed, you can enable. It's an optional one. When you write a contract, in this case, it is like an L2 access ACL, L2 ACL, A2 ACL, MAC ACL. You can also see this output in the CLI of Epic CLI by typing these commands. So what we saw just now is L2 out. For that, two things only: bridge domain and then external bridge network L2 out. Those two things we create, we map. Now L3 external network connectivity, L3 out. L3 out allows ACI to communicate with the external network at layer 3 using the routing protocols like OSPF, EIGRP. No EIGRP supported in ACI now. OSPF, BGP, and static route. Yes, no EIGRP support. You got OSPF, BGP, and static route. So you want two routers. One is ACI fabric, another one external router to form neighbor. We call it as L3 out. Scenarios: connecting to the internet or external WAN, or routing between ACI and non-ACI environment, enabling hybrid cloud connectivity. Makes sense. So how it works, a logical node profile defines the external routers. So that is the first thing that we need to have. Logical node profile. Another one is logical interface profile, assigns interface to the L3 out. Logical interface profile. And then ACI will act as a router using one of this protocol to advertise and form name. External connectivity using SVI or subinterface or router interface. Let's see configuration example. This scenario is to ACI must connect to the external router using BGP over a routed interface, layer 3. Definitely you need a VRF. This is how we create VRF because it's layer 3. And then external routed network. See? Yeah, that we need to create. Tenant networking. This thing we know, tenant networking, even for layer 2 out, we went to tenant networking. But this time we are getting into external network, external routed network. And there we see an option, new L3 out policy. There we also map the VRF which we created in the previous step. And then a logical node profile we create. What does that mean? The router needs an autonomous system number. See, this VRF that you created, it's a virtual router, which is going to talk to the external physical router. Now, this virtual router, this internal router needs to talk to an external router with an autonomous system to form neighbor. So We define the external router node, okay, um, with router ID and autonomous system number. This autonomous system number should match with the external router. That is why it is called as external router node, but this is not external router node. This is to identify the external router node. Next is configuring logical interface profile. One of the leaf only will be connecting to a external router. So that leaf port needs to be assigned, and the IP address and the subnet mask on that leaf port. All these things, we will be typing inside a template. All these things. And then what routing protocol you are going to use. And then apply if any contract is needed. This is only if it is needed. Route map and redistribution. Maybe when you say BGP, definitely will have some attribute. Such things can be attached. Right, this is to form eBGP or IBGP neighbor with external router, ACI. It depends on the autonomous system number whether it is eBGP or IBGP. Right, these are some commands that you can type and see whether it is running on the leaf, that particular leaf where you enabled the leaf port, that particular leaf, you can go and check this. Right, so a few more verification commands. Show endpoints, show IP interface brief, show IP BGP summary. That's going to show you the neighborship, BGP neighbor, OSPF neighbor, VLAN extended, that is for layer 2. Testing, you can ping and test, trace route and test. All right. Please go through this. If there is any question, you let me know. This is the end of this chapter. This chapter is talking about L2 out and L3 out. What does that mean? What is the difference between the previous chapter and this chapter? In the previous chapter, the VXLAN decapsulation happens on leaf. Decapsulation happens on leaf. Whereas here the extension is going down to the outside ACI device. It is not ending on leaf to leaf. It may be, traffic may be initiated from a leaf, entered into a leaf, but exit is on a classical network because we have extended VLAN 100 to the outside switch, or we have extended the layer 3 to outside router. So the BGP which is within the ACI is also now extended down to traditional switch. So you can say the border of ACI is not on the leaf, it is on the outside US because the extension is done to layer 2 and layer 3. That is how you have to see this. Right, this is the next chapter, virtual machine manager integration, meaning, see, there is very popular VMware, vCenter, vSphere, very popular in VM, virtual machine. VMware is the company. Likewise, we have many other virtual machine vendors like VMware. The popular one is VMware only. So Cisco ACI can integrate, can adapt, can include the VMware inside the ACI fabric so that you can have VMs, we call it as VMM domain. We can have VMM domains, not just physical routers, physical computers, and physical switches. You can also have VMM domain connecting to the ACI fabric. You can move one VM from one physical hardware to another physical hardware. We call it as vMotion. All these things are even supported in Cisco ACI. Further, what Cisco ACI need to do is Cisco ACI should go and get that vCenter merged with it. vCenter and ACI should get merged. In another word, ACI should understand vCenter and vCenter should become part of ACI. If that happens, we call it as integration, integrated VMM integration. Virtual Machine Manager integration in ACI. Cisco application-centric infrastructure provides seamless integration with Virtual Machine Manager (VMM). Platforms such as VMware vCenter, Microsoft SCVMM, and Red Hat OpenShift. These are all popular. Cisco can work with all these things. VMM integration in ACI allows network and policy automatically for virtualized workload, ensuring consistent security, segment, and network provisioning across both physical and virtual environment. So this is what I just said. You not only have a physical device attached to the ACI, you can have virtual device. For those virtual device, you can have policies same like what we used to have for physical device. Putting a VM in a VLAN, setting some rate limit on the virtual port on the virtual switch where the VM is connected. All those things can be done same like what we used to on the physical ports. We can now do it on the virtual ports on the virtual switch, virtual distributed switch. For that, what ACI should do is simple. ACI should adapt vCenter. vCenter already do these things. Port profile, port policies. vCenter is already doing these things. Now, if ACI will go and talk to vCenter, and if ACI can understand the language of vCenter, now ACI can control vCenter. ACI can dictate the vCenter. ACI can make the vCenter decision according to what we put configuration on ACI. We no need to go to vCenter and configure things. If ACI and vCenter gets merged, I'm going to show you the steps in the next slide. They both need to get authenticated. ACI engineer should know the IP address and the vCenter password and the VLAN, infra VLAN. Instead of vCenter has got one infra VLAN. Mostly it will be VLAN 4. If an ACI engineer knows all this thing, that is enough. What is VMM integration? VMM integration in ACI allows EPIC, which is the orchestrator of ACI, to communicate directly to the virtualization platform like vCenter, enabling automatic configuration and management of virtual network. So now from where the virtual network is configured, automated from the ACI. Automated network provisioning, EPIC automatically configures virtual switches that are needed, VLANs, VXLANs. All these things are created on the virtual switch. It's not a physical leaf. You have a virtual leaf now to which a lot of VMs are connected. So the VXLAN tunnel ends and exits on VM switch. We may be communicating from a physical device to a virtual device, which means what? The VLAN need to be extended from physical leaf to the virtual leaf, which is possible through VMM integration. So here the leaf is a virtual switch. So in this picture, we can see here there are two different VMM domain. One is by VMware vCenter, another one is by Microsoft. Now we got four VMs on each domain, and we want the communication from, let's say, A to B. Now this may be physically connected to this leaf, and this may be physically connected to this leaf. But this is a virtual switch, VM switch. And now this may be a member of VLAN 100, this may be a member of VLAN 100. Now how these policies are applied, VLAN 100, all this stuff, through EPIC, which means ACI is extended down to this one. So though this is a leaf, let's say called as leaf 5, that leaf 5 has got like a FEX port, fabric extender. So now you can have a visibility down to these ports now in the EPIC. In the EPIC, you can see these ports very clearly, which is there on the vCenter V switch. So you don't need to go to vCenter to configure or SEBMM of Microsoft to configure. You can do everything from EPIC itself. That is what here it means, automated network provisioning. You don't need to manually go to those virtual switches to configure them. EPIC can automatically configure those virtual switches with necessary configurations like VLANs and VXLANs. Also the policies. So there is no separate policy configuration for VM and ACI. There is a policy consistency. Same like what you do for physical device, you also do the same way of configuring for the virtual device. Policy consistency. And not only that, the endpoints, the VMs, when they move from one leaf to another leaf, or when they move from one virtual switch to another virtual switch, they are dynamically tracked and learned. See, tracking VM movements and updates the network topology dynamically so that wherever the VM moves, the policy also moves along with that. Okay, how this VMM integration works in ACI. What does this ACI do? It pushes the necessary program and try to merge with the virtual platform. Epic connects to the virtual platform using the programs, APIs. That's what it means, API call. API is trying to discover the virtual platform. The integration creates VMM domain, which maps the ACI objects like EPG and contracts. We learned like for 5 chapters before what is EPG, what is contract. Now there is a domain which we created for VMM now getting mapped to this EPG and contract, because now EPG is to identify the endpoint. The endpoint here is a VM, not the physical device, but still they need policies. Same like what we have for physical device. Yeah, physical policy consistency. It's same. Virtual switches like VMware VDS means virtual distribution switch or Cisco ACI virtual edge receives configuration from Epic dynamically. When VM is created or moved, Epic updates the network policy automatically. So wherever the VM moves, the policy goes. Simple. What they are trying to tell us is with this VMM integration, you can configure on ACI same like what you used to configure for a physical device that connects to the ACI fabric. Even though it's a VM, you will have a visibility to those VMs, which is not physically connected to the leaf. It's connected through a bare metal deployment, a bare metal server to the physical port of leaf, and the leaf is a part of VMM domain. As I told you, that becomes like a fix. That virtual switch becomes like a fix for the leaf. Now, integrating with VMware vCenter, these are the steps. Why integrating ACI with vCenter? VMware vCenter is a virtualization platform which is widely seen. When we integrate, we can automate it. We can have policy consistency. We will have visibility. V means what? Epic. Epic will have visibility down to the virtual switches, virtual leaves, virtual machines. So you no need to go and do everything manually. You no need to do configuration on vCenter and then come to ACI, do config. No need to do like that. You can merge both, and you have one plane of glass called Epic to control even the VMM. Same like what you used to control, how you used to control the physical one, here you are controlling VMM. These are the configuration steps. First, you need to create VMM domain and then register the vCenter in Epic. For that, you need to know the IP address of the vCenter, password of the vCenter, and then create and associate VLAN pools that are going to be used in ACI as well as in VM. And then associate the VM domain to an attachable entity profile. Very important. Attachable entity profile is like a glue that connects between all components of ACI. You might have created VLAN pool, you might have created port profiles. Now, what combines all this? Attachable entity profile. Here we created VMM domain, so we need to associate. And then we say which EPG and which port groups belong to this VMM domain. At last, we verify by clicking VM network and VMM domain in the EPIC. You will have visibility to all the V switches in the V center. Now, these 6 steps, these things need to be done in labs actually. It's an easy lab only because we have not gone through that lab exercise or seen the pages. It may look like a tough thing. No, it's not that tough. Simple, you need to know the steps, where to go and what to click. See, to register vCenter, you should not go to Fabric, you should go to System. But for creating VMM domain or creating VLAN pool, you went where? Fabric. Registering vCenter is with the ACI, the system itself. So go to System Controller, VMM Controller. There you will have a option to add vCenter. When you click on that, you will have a template where you should provide the IP address and the credentials. All right. Next is resolution immediacy data, meaning what? It means how ACI can track or when the deployment need to be done. See, deployment can be done for VMM domain in 3 different ways. One is beforehand, even before the virtual machines were created, you can keep it ready so that when a VM is connected immediately, the necessary policy can be pushed. The other one is on demand. Whenever you need, you go and create and you push the necessary configuration, you push whenever you need, not beforehand. The other one is you create everything but don't deploy it. You make ACI to push it whenever it finds the EPG connected. 3 ways. Okay, first of all, let us read what it is. Resolution immediacy determines when the ACI policy is pushed. When it is going to be pushed. How quickly ACI will react to the VM related change. How quickly? You can decide how quick. You can say immediately. You can say after all the deployment or on demand. There are 3 different options. How quick ACI will react to the VM related change. In another word, this setting determines how and when ACI learns and resolves the endpoint within EPG. These are the 3: when, immediate, on demand, pre-provision. Immediate, as soon as you configure, policies are pushed. Policies are pushed to the VMM platform like vCenter as soon as they are configured in Epic. When do we use this? Useful in the scenario where endpoints are static or need immediate policy enforcement. Second when is on demand. Policies are applied only when VM is attached to the endpoint group. When you attach, it goes. Idle for dynamic environment with frequent endpoint change. Meaning, if you remove the VM, the policies withdraw. Will withdraw. When you attach, the policies will be enforced. It is ideal for dynamic environment with frequent endpoint change. That is the scenario where we will do on demand. The third one is pre-provision. Policies are pushed to all hosts in a cluster regardless whether the VM is there or not. It is sent to all the vCenters even before the VM is running. So this is good for non-changing endpoints. You don't move often. See, wherever you do vMotion kind of thing, then on-demand is good. So these are the three ways in which ACI can push the policies, apply the policies. One is immediate. As soon as you configure it is pushed. Second one is on demand, only when the VM is connected to the endpoint group, to the respective ports, the policy is pushed. Pre-provisioning, beforehand only you go and push all the policies to the appropriate ports. These are the three. Resolution immediacy. Resolution immediacy is nothing but determining when the ACI policy need to be pushed to the VMM controller. Immediate as soon as you configure the policy. On demand, you configure but not pushed until the VM is attached to the VMM. The third one, pre-provisioning, it is pushed and kept ready on all VMM controller on all the respective ports. That is pre-provisioning. And how to configure it? Go to tenant, application profile, EPG, static path binding, resolution immediacy. There you will see these three options. You can choose any one of these: immediate, on demand, pre-provision. Right? So this chapter is about VMM integration. The previous chapter was about layer 2 and layer 3 out. External network connectivity in ACI.